Hey everyone, it's your friendly neighborhood science man here, Aaron Dizzle, don't get it twizzled. Today we're going to do a lab simulation of what tends to go on in the small intestine with molecules of food that are getting digested and their size and how the size of the molecules affect their ability to go from the small intestine into the bloodstream. Okay? So today at your table, you'll have a little bin, clear bin with another bin that you've seen before in another lab that we've used. And so this is what you're going to start with, and I'll see you in a second over at the lab counter behind us to see what we do next. Okay, so I'm over at the lab counter. One partner will bring your little bin and fill it up with water, probably about halfway or 3/4 of the way up. So you do that in your sink. While one partner is doing that, the other partner is going to grab dialysis tubing and 2 strings. Okay, so here is one dialysis tubing. Now, dialysis tubing is used for, again, for patients who have issues with their kidneys not being able to filter out their blood. And this tubing is inside a machine that their blood will go through. It traps the gunk, the bad stuff, the waste that your kidneys would normally trap, and then the clean blood can continue to go through and come back to your body. So we're going to use this. It actually is a bag. It's a tube, but right now it's a flat, looks like a piece of tape. What you're going to do is you're going to dump it in the water, all right, and let it soak for about 10 seconds or so, and grab 2 strings and go back to your table. Okay, so I'll see you in a sec at your table. Okay, so we're back at our seat, and right now I am going to try to manipulate this little piece of dialysis tubing to see if I can open it up. Kind of like you need to open up those fresh trash bags that you have from the store to be able to put into a little trash bin at your house. You're going to do the same thing. You're going to kind of twist back, like rub back and forth to try to get it to open. And sorry, my gloves are giving me issues. So I'm going to take it out of the water, and I just start to rub back and forth, okay? And until I get a little opening in the top. Waiting a few seconds. Usually as it starts to dry, it starts to get a little bit easier to do because you get a little bit of friction that happens to allow you to open this. Okay, and there we go. We're starting to get it to open. And so now that I have one end open, okay, what I could do next is take a pipette and poke it through the top just to kind of open it up a little bit. So let me go grab my pipette so we can do that. Okay, so what you can see here is I've got the bag open just a little bit. It's hard to see, okay, in the top, and this will allow it to kind of open a little bit more. Now, I don't want to go all the way to the end because this next procedure is important. You're going to tie the other end by folding over. Okay, so I'm folding this end over once and then slightly over again. Okay, and then I'm going to twist just a little bit, almost like a candy wrapper is twisted, and the other partner is going to tie that end with the string. Do a double knot, okay, kind of like you would do when you're tying your shoes. Do a double knot on that end. Okay, so as you see, I have one knot so far. I'm going to do another knot. Okay, and so now this end should be secure. Nothing should be able to leak out of it. Okay, so now I go back to making sure I have this side open. Started closing up on me already. Sorry, I'm going to pause. So what I did to help me get it back open again, you just dip it into the water and then it's able to open again. Okay, so now that we have this open, we're going to go back over to what's right behind me where we have starch and glucose. See you there in a second. Hey, back over here. So what you're going to do is, this is the starch right here. Okay, so this represents the complex carbohydrates that we were seeing in our data from the food molecules with the graham crackers yesterday. And so starch solution is going to be kind of like a cloudy water. And so this is cornstarch. What you need to do is you need to take a full pipette. Okay, so I sucked up this much as the pipette was able to draw up, and I add it to the bag. Okay, so that's about half full right now, which is enough. Then I go over to the glucose. This is the sugar. Remember, this is what is found inside a starch. A bunch of these glucoses bond together. It can make our starch or our complex carbohydrates. So this would be sweet. This would be like the non-sweet carbohydrate. This would be the sweet carbohydrate. Okay. So this is a glucose solution. It just looks like clear water, but there's a lot of sugar that's been dissolved into it. And you're going to also put the other half, fill the rest of this dialysis tubing, but make sure you have enough space to be able to twist it and tie it. Okay, perfect. Squeeze the rest back in there. Then you're going to go to the sink and do something very important. Hello again. This is me at the sink. All right, so you're at the sink. The reason why you're at the sink is because you're about to tie the other side. So make sure you're at a sink and you have one partner has other string. What you're going to do, again, you're going to fold it down, and you're going to have some of this liquid is going to escape, and that's okay. Fold it down and then just twist it. Okay, twist it, and then have the other partner tie this side. So it almost looks like a Jolly Rancher when you're done. Let's see how I do. See you in a second. Aha! I did it! All right, so now I have what looks like a piece of candy, all right? But this is representing our small intestine layer, our skin layer of small intestine. There's also a muscle layer, all this different kind of tissue that makes up the lining of the small intestine. And we have food inside. We have starch and we have glucose, okay? So it's as if you just ate a graham cracker, or in this case, McKenna ate a graham cracker, and inside of her small intestine is starch and glucose. And we're going to try to learn to see which items can get in or out of this bag of this small intestine. This small intestine has tiny holes in different areas that will allow certain things in and certain things out. We're going to learn what things are able to enter and exit. So how are we going to do this? Well, first, you have to do this procedure. You got to rinse off this bag of glucose and starch, because you don't want any that got out when you tied it to affect our experiment. You want everything to really be inside. You don't want any of it to be contaminated on the outside. Okay, I will see you in a sec. All right, back at the table. And the next thing I'm going to do is I'm going to take this dialysis tubing with starch and glucose inside. I'm going to place it into our cup full of water. Now this cup full of water represents the bloodstream, and which is coming up in contact with the small intestine. And normally this is where you get the transfer of nutrients from the small intestine to the bloodstream to be taken throughout the whole body for the cells in your body to use the nutrients, the nutrition, okay? So you place it into that cup of water, bowl of water, and I know that there's some initials on here already. You can cross those initials out with permanent marker, and you can put your group's initials, okay? Some way to kind of remember yours. This next step is very important. Hello. Okay, so we're over here at our final station, our final area for today for what you need for this lab. This is iodine. Okay, now iodine does a great job. This is, we learned about iodine in a periodic table. This is actually not straight up iodine. It's a compound. Okay, and so it's bonded with another element, but it has the element iodine in it that we're trying to use its properties. Iodine, when it touches starch, turns purple black, okay? And so if you were to take a cracker, like our graham cracker yesterday, which has starch in it, and you drop some iodine on it, it should turn purple black. Even paper has starch or complex carbohydrates in it that, like cellulose and other materials that turn purple black when it touches. Basically, if it comes from plants and it has multiple sugars bonded together, it should turn purple black. So what we're going to do is we're going to put iodine drops into this water on the outside. I'll be right back. Okay, I am back. Sorry. So you have these pipettes. Again, stay here with the iodine. We don't want to cross-contaminate them with anything else. So I'm going to draw up as much as I can, and then on a count. 1, 2, 3, 4, 5. Let me get the camera able to see this a little better. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, that's about 30. And it's okay that you put the rest back in this case, because I'm going to be using this all day with my students, and these are from the original iodine container, so these are going to be for the class to be used today. So as you see now, the iodine has a nice kind of brownish color as it's concentrated, and then as it's diluted into the water, it becomes a little bit more of like a lighter brown. Okay, we're going to let this sit overnight, and you need to think about what we know about iodine. We just learned about iodine and what's in that bag, aka the small intestine. What do you hypothesize will happen after 24 hours? Okay, so when we come back tomorrow. And so don't forget, we also have sugar inside of there. And so when iodine touches sugar, nothing happens. But if sugar can get out, we can test this water with something else tomorrow to see if sugar was able to get out. Or if starch gets out, think about what might happen to the water outside that has iodine in it. Or if iodine is able to get in, think about what might happen inside of this bag if it does do that. So, okay, have fun.